Alright, we're at Unit 3, Video 1. We're solving right triangles, sides only. So we're looking here, and this is a review of trying to find the missing sides of a triangle. So let's go ahead and try a couple examples together. So we're going to start by reviewing how to label a right triangle, something that just to be sure we've all got. We're going to label, it doesn't matter if this is A and this is B, but we always want to make our right angle C, so if you've switched A and B, that's fine. However, across from angle A is little a, so if you've switched, you've also switched that. And across from angle B is little b, and the hypotenuse is always little c. Hard to find the difference between little a or little c and big C, but we've got it. We know that C is always 90 degrees, so this is obviously our side length. Alright, so we're going to focus on finding the missing sides of a right triangle. So our first example is going to have a side length of 9 and a hypotenuse of 20. So if all I care about is finding the other sides of the triangle, I think using the Pythagorean theorem is your best bet here. I don't know the angle measures, so that's not really helping me at all. So if I have 9 squared plus something squared equals 20 squared, go ahead and take a second and make sure you're careful with your calculations. Alright, because all of my original information was given as whole numbers, my answer should also be given as a whole number unless indicated in the directions. There's nothing in my directions here that say I have to round to a certain amount. Therefore, I look back at the problem and I say my original information was given as whole numbers. They're integers. I do not use any decimals, therefore, in my answer. So the missing side here will be 18. Well, it wasn't 18 on my calculator, it was 17.860571. But again, because I'm given whole numbers, my answer is a whole number. Let's try number 2. Here I've got 5.4 and 13.1 as my legs. So we're going to use the Pythagorean theorem again. Go ahead. Now this time, because I have a 1 decimal place here, I've got the tenths place, then my answer is going to be given to the tenths place, and I'm going to round accurately. So my calculations here will now be 14.2. My calculator said 14.169333308, but I want to round accurately, so I have 14.2. We got a couple more. Example number 3. If I have a side length of 20 and an angle of 35 degrees. Now my job is to find the missing sides. This time I've got 2 missing sides. So I'm going to have to use a little bit of trig. I have enough information to find this because I have a right triangle. I'm going to use our SOHCAHTOA. Okay, so if I have right here an adjacent and I want to find the opposite, then I'm using tangent. So I have tangent of 35 degrees equals a missing side over 20. Okay, so go ahead and calculate that. Make sure that your mode says degrees. So you need to check in your calculator that your mode is under degrees because I'm using 35 degrees. Please check that. Okay, my side length was given in a whole measure, so I'm going to use the whole measure as my answer. So I have 14 as this side. Now that I've got that, I can go ahead and use the Pythagorean theorem to find the other side, or I could use that I know that I can find sine or cosine using tangent of 35. So I'm going to go ahead and use that. I'm going to use trig. So I have let's go with, I got this random 14 that I wrote down here, so I'm going to use sine. So I have sine of 35 degrees will equal 14 over my hypotenuse. Now to do this, I'm going to have to switch these two, which is completely acceptable. So C actually equals 14 divided by the sine of 35 degrees. 14 divided by the sine of 35, and I get 24.4. So I'm rounding this to the whole number, so it's 24. Last example here. Let's go ahead. I'm going to have 19.22 as my angle measure and 15.35 as my hypotenuse. So I can start by finding either sine or cosine. I'm going to start with sine, so that means I'm finding this side. So I have the sine of 19.22 degrees will equal something, I don't know what it is, over 15.35. When I round and I find this answer, I am looking for the hundredths place because it's given in the hundredths. So I found this side length right here to be 5.05. I can use the Pythagorean theorem to do this. If I do that, it's best if I use the number that's already in the calculator. So that means I'm going to have a squared plus the calculator number that I just found, the 5.05 squared, equals 15.35 squared. The reason I want to use the calculator number is I've rounded, and if I go ahead and I just use the rounded answer, then I'm creating a rounding error within my problem. So I'm just going to use, I'm going to square the answer. Now I'm going to take 15.35 squared and I'm going to subtract that. And then I'm going to take the square root. So that leaves me with, rounded to 2 decimal places, 14.49. All right, good job.